Okay, so this video is meant for my students in Concepts of Algebra 2. We have a quiz coming up on Thursday covering sections 2.1 through 2.4. A lot of material, so here's a YouTube video that you may bring in for bonus and use on the quiz. Alright, so we'll do a couple of problems. Here's the first one. Identifying functions. Identify the domain and range, then tell whether the relation is a function and explain. Okay, so I am given a set of ordered pairs. Alright, x comma y's. Remember that the x's make up the domain and the y's make up the range. So for the domain, I look at all of my x's. That'd be 5, 3, 5, and 2. And I'm going to put them in numerical order without repeating any of them. So 2, 3, and 5. The range is then going to be all the y's. So that would be 4, 1, 0, and 7. Again, in numerical order and without repeating. 0, 1, 4, and 7. So there's the domain and range. Now, is this thing a function or not? Well, remember a function. Each x can only have one y. Okay? Cannot break off into two. Well, look here. 5, 4, 5, 0. That means the x5 is going to 0, and it's going to 4. This is not a function. Now, we can also use this idea of this vertical line test. Let me slide this down. So remember, we could graph this. I'll just do a quick graph. 5, 4, 3, 1, 5, 0 right there, and 2, 2, 7. 1, 2, 3, 4, 5, 6, 2, 7. And now if I draw a vertical line through this graph at any place, watch. It hits both of those points, 5, 4, and 5, 0. And that's a no-no, right? Vertical line cannot touch a relation twice for it to be a function. It can only touch once. So this is again why it's not a function. Okay, so here's our second question. It talks about hot air balloons. You can read the problem yourself. The important thing is that the height of the hot air balloon is modeled by h equals 250 plus 6t, where t is the time in seconds. Okay, so h is the height in feet, t is the time in seconds. So the first thing they want us to do is make a table of values, with t being between 0 and 60. So I'm just going to pick a couple values. So we're going to make this table. Remember, input variable is t. What am I plugging it into? 250 plus 6t. The output variable is h, and my ordered pair for my graph is going to be t comma h. Input comma output. Okay. And here is my table. And I'm going to pick some t values. Now I'm going to start with 0. 0 is always the easiest because when you plug 0 in for t, it makes the t term go away. And you get 250. Simple. And that's the point 0, 250. That's where it's going to start. And then I need to pick, let's pick two more points between 0 and 60. And let's just make them nice. So let's pick 10. Sure, 10. 250. Plus 6 times 10, that's 250 plus 60, that's 310. So the point 10, 310 is also on this graph. And then let's go all the way to 60. So 250 plus 6 times 60. 6 times 60 is 360. 360 and 250 is 610. So the point 60, 610. Is on our graph. So we have these table of values, and now we're going to make our graph, and this is the second part. So here's my graph, and my independent variable or input variable t is on the x-axis. My dependent variable or my output is h on the y. My t's can go from 0 to 60. So let's count by tens. So 10, 20, 30, 40, 50, 60. 10, 20, 30, 40. And now if you look at my y values, they seem to keep getting higher and higher. 250, 310, 610. And 250 is the first one. So it's going to be smart of us to put a break here. and make that first value 250, and the last value just has to be 610. So why don't we make it 650? And to get from 250 to 650, let's count by 50s. 300, 350, 400, 450, 500, 550, 600, 650. 300, 350, 400, 450, sorry, that's bad. 450, 500, 550, 600. And again, you don't have to put all the numbers there. You can just put like the hundreds or the 50s. I don't care. But show me that you're counting by 50s. And now we'll graph. And I'll put them in red. 0 to 50. 10, 310. So just above 300. And then 60, 610. Just above 600. And hopefully, and I'm not very good at straight lines on this thing. Hopefully it'll go in a nice straight line. And you could keep it going if you wanted to, I don't care. But because the domain stops at 60, this really should just be a segment. It should just be from 0 to 60. And that's exactly what we graphed. So you can make sure you make that table, fill in the important information, get your points, and then graph, picking appropriate axis labels. Okay, so our next problem here, identifying linear functions. Tell whether the function is linear or not. So we need to see if it is in the form, y equals mx plus b. So linear means, so if you want to make a note, linear means y equals mx plus b. Now y is the same thing as these function notations, so don't be afraid. So again, this is f of x equals negative 3. Is it in the form y equals mx plus b? Well, if it is, we should be able to identify an m and a b. Well, watch this. F of x equals, now notice it has no x in it, but what happens if I make m a special number called 0? 0 times x is 0, and that goes away and leaves you just with that constant, that b term. This is linear. Even though it has no x, it is linear. The m is 0, and the b is negative 3. So that was kind of a tricky one, so I'm going to throw it on there to show you that it can be linear even if there's no x there, okay, if it's just a constant. Now if you come over here to b, look at b. Can it be written in the form mx plus b? Well, look at this guy. That's an exponent. No exponents allowed. Not linear. If you have an x in this problem, it better be just x, not x squared, not x cubed, not x to the fourth. So this is not linear. Here's our next example, and we're going to evaluate a function. Now if we take a look at this problem here, you might see this a little bit differently on your quiz. You might see, here's the function, and they might say, what is h of 2? Okay, for this one. So we need to know that we need to plug in 2 for x. Okay, that's the idea. So in this first one, we'll call this a, you can call it 20, whatever. H of 2 equals, and we replace x with 2. Negative 2 times 2. Well, we just simplify that, that's negative 4. There we go. For the second one, again, you might see the functions are, what is r of negative 1? You might see that on your, instead of seeing this x equals negative 1, r of negative 1. So that means let x be negative 1 in the function r. So r of negative 1 equals 6 times negative 1 to the third minus 4 times negative 1 squared minus 3. Notice the parenthesis usage. We should do the powers first. Negative 1 to the third is negative 1 times negative 1 times negative 1. It's a negative 1. Minus 4 times negative 1 squared is negative 1 times negative 1. That turns positive. Minus 3. Do the multiplications. This is negative 6. That's minus 4 minus 3. Left to right. Negative 6 minus 4 is negative 10. Negative 10 minus 3 is negative 13. And there's r of negative 1. It's negative 13. Okay, in this problem we're going to talk about slopes and steepness of lines. Okay, so we need to figure out which line is steep. And all you have to remember is the greater the slope, the greater the steeper the line. Okay, so bigger slope, steeper the line. So starting with line 1, let's find its slope. Now we should remember and hopefully you write this down. Slope is y's over run, right? Y's over run. y2 minus y1 over x2 minus x1. So in line 1, we have 2 y's and 2 x's. Let's subtract 3 and 9. So 3 and 9, and then go to 5 and 1 for my x's. That's negative 6 over 4, and this will simplify to negative 3 halves. I can divide each by 2. Negative 3 halves. So I'm going to leave that alone. I might have to look at that as a decimal, but I'm going to leave it alone right now. So now we go on to the second line. Let's use blue. So for line 2, you can do the y's, negative 1 minus 3 over the x's, 1 minus negative 3. Notice what I do with the negative 3. I write it next to the minus sign. I know that a minus and a minus make a plus. That's fine. Okay? So that's going to be negative 4 over 4. And that simplifies to be negative 1. Okay. So my two slopes are negative 3 halves and negative 1. Remember, we don't worry about the negative. We worry only about the positive slope when we're talking about steepness. So really, we need to compare 3 halves to 1 and ask ourselves which one is bigger. Well, hopefully you know that 3 halves is also 1.5, which would make 1.5 bigger than 1. And if we pick the line with the slope of 3 halves, so the slope of 1.5, and that is line 1. So line 1 is steeper. So again, ignore the negatives. Just think of which number is bigger, 3 halves or 1. Okay, so here's a rate of change problem, okay? So if you read through this problem, you'll see what is the average rate of change. And we need to know that rate is just slope, okay? So when you have slope, you need to usually find 2 points. So let's see what we got in this problem. It says you're camping. You're camping at an elevation of 82,000 feet, and it's 75 degrees at your camp. So we need to put those two together. 8,200 feet with 75 degrees. So feet with 75 degrees. Then it says it's 104 degrees along the Colorado River at the bottom with an elevation of 2,400 feet. So we need to put 2,400 feet with 104 degrees Fahrenheit. And notice what the question says. What is the average rate of change in temperature with rising elevation? They put temp first. That means temp goes on top and elevation goes on bottom. That means degrees Fahrenheit on top over feet on the bottom. Okay? So these are our points. This is the x, this is the y. X and y, because your degrees Fahrenheit go on top, your y's go on top. So how are we going to fill in this slope formula, or this rate formula? So rate equals, so let's take the y, 104, minus 75. 104 minus 75, let's do 2,400, minus 8,200. And I'll get my trusty calculator out, and I'll do 104 minus 75, and I'll get 29 for the top. And the bottom, 2,400 minus 8,200, we'll get negative 5,800 on the bottom. And you can just give me a decimal, that's fine. So this comes out to be negative 0.005, and that's your rate. Negative 0.005, it's the degree Fahrenheit, it's the top units per the bottom unit per foot. And there is the change in temperature with elevation. Negative 0.005 degrees Fahrenheit per foot. Okay, 2 more problems left. So we're going to take this standard form equation and we're going to graph it. So let us remind ourselves that standard form means x and y are on the same side. This is an ax plus by equals c form. So what we will do is we will find the x and y intercepts. So to find the x-intercept, we're going to cover up the y. So I don't have anything to cover up with. I will put a line through it. Okay, so I'm covering up the y. So when I cover up the y, notice it says 3x equals negative 10. Now I'm going to undo my cover up and write 3x equals negative 10. And now I have to solve this for x by dividing by 3. And I get x equals negative 10 thirds. That's the same thing as negative 3 and a third, or 3 repeated. So that is my point. I have an x of negative 3.3, and the y, since I covered up the y is 0. Now, to find the y-intercept, I will now cover up the x. So when I cover up the x, I see 4y equals negative 10. That's what I will write down. 4y equals negative 10. I'm looking for the y-intercept. Get y by itself by dividing by 4. And this simplifies, and again, I would do a decimal. You could do negative 5/2, right? Divide each by 2. Or negative 2.5. That's 2.5. Okay? Either one works. I think decimals are easier because you can plot them better. Fractions, you get confused and think it's a slope. It's not a slope, it's a point. So for that y-intercept, the y is negative 2.5 and the x is 0. And now I plot. So on my x-axis, I'm going negative 3.3. That's between negative 3 and negative 4, right there. On my y-axis, I'm going down 2.5. And here's my line. And there we go. So that is with a x-intercept of negative 3.30 and a y-intercept of 0, negative 2.5. There we go. Okay, so here is our problem. We're going to graph the line. So let's do that first. Let's graph the line. Here's the line I've given you. Y equals negative 1/2 x plus 4. So let's first understand this is slope-intercept form. Right? The m is negative 1/2. The b is 4. So remember that b means that's the y-intercept, 0, 4. So I'm going to grab axes real quick. Okay, so I got my axes up, and I'm going to graph this. I'm going to start, and I'll do this in red. I'm going to start with the y-intercept. Go up 4. 1, 2, 3, 4. And now I'm going to count this slope. This slope means down 1 and to the right 2. Down 1 and to the right 2. And there's the first line. And pardon my poor line drawing skills. There's my first line. Maybe I'll try to make that a little bit better. There we go. Look at that perseverance, right? Second time's a charm. So that's the first part. So I graphed the line. Now, on the same grid, so now we have part A. Graph the line passing through 1, 1 and parallel to the line. Well, if it's parallel, then I know the slopes are equal. So if I can identify the slope of the first line, I know my slope. So the slope of the first line is negative 1/2. So that's the slope of my line I have to work with, negative 1/2. So I have the point 1, 1. So graph the point 1, 1. And that's terrible, so I'm going to use a darker color. I'm going to use purple. Okay, so 1, 1. And I'm going to count down 1 to the right 2. Down 1 to the right 2. And there's my second point. And when I graph that line, look, it's parallel. They don't touch. That's exactly what you want. So if it looks parallel, then you got to figure that you did it right. Okay? All right. So that was A, part A. Now part B. Now the line perpendicular to the original line at its y-intercept. Okay. So two things. Number one, we need to know that for lines to be perpendicular, we need opposite reciprocal slopes. So opposite and reciprocal. That's terrible. Opposite and reciprocal. So if I look at the original slope of negative 1/2, The opposite, so the slope we're going to use, so this is the slope of the first line. The slope we're going to use is the opposite, which is positive, and the reciprocal, 2 over 1. There we go. The second thing I need to do is I need to grab the y-intercept of the original line. Well, the original line had a y-intercept of 0, 4, so that's the point I use, 0, 4. And I'm going to graph this in blue, so this is going to be in blue. I will go to my y-intercept of 0, 4, so it's the same point, but now I'm going to count a slope of 2, 1. Up 2 to the right 1. And then, ooh, look at that line. That's straight. And there's that line. And there's B. Okay? So first line is drawn. Second line is parallel to that line through 1, 1. So maybe I'll put 1, 1 right there. And third line is perpendicular to the first one at its y-intercept, which is 0, 4. And to be perpendicular, opposite reciprocal slopes. Negative becomes positive, 1/2 becomes 2 over 1. Okay, so thanks for watching. I hope this was helpful, and we'll see you on Thursday.